Hi, in this recording, I will review some examples of transaction exposure. So we will start with a simple question. In this case, Cray Research sold a supercomputer to a company in Germany, Max Planck Institute in Germany. And the sale was on credit, and the customer was invoiced about 10 million euros, which is payable in 6 months. Currently, the 6-month forward exchange rate is at $1.10 per euro, and the FX advisor for Cray Research predicts that spot rate is likely to be $1.05 per euro in 6 months. So this is the company's expectation. So with this expectation, if the company does nothing, and if really the expectation proves to be the case, the company will be able to clear about $10,500,000 from this sale. However, the prevailing forward exchange rate is 1.10 per euro. So the company actually, by getting into a forward rate, can clear $1,100,000. So given this, what is the expected gain or loss from a forward hedge? That is, if we enter into a forward contract, and if the expected spot price transpires, will there be a forward gain or loss? The second question related to this, that if you were the financial manager of Cray Research, would you recommend hedging this euro receivable, given the expectation that you have exchange rate of 1.05, would you hedge this position? It's about 10 million euros. The third question is, suppose the foreign exchange advisor predicts that the future spot rate will be the same as the forward exchange rate quoted today. Would you, in that case, recommend hedging? And we should answer why or why not. Finally, there is a scenario where we assume that the spot exchange rate is forecast to be 1.17. And what we would be under these circumstances, should we hedge the position or not? So we have a forward rate available to us, and we are asked to entertain thoughts about the hedging decision based on several anticipated future spot rates. So let's move on and see if we can answer the question. So first of all, in part A, as we mentioned, if we enter into the forward contract, the 1.10, the exchange rate of 1.10 will actually lock us to $11 million. So we will be able to clear $11 million out of the forward sale at the expiration. If the firm does not hedge and the expected spot rate prevails, the amount that we will clear would be $10,500,000. Now, if the company hedged, that is, if we locked into this $11 million deal, and if the spot rate turned out to be 105, we will have a hedging gain that is forward actually will deliver us a $500,000 more value than what we would get without a hedge. So in this particular case, there is a hedging gain involved. If the exchange rate turns out to be, let's say, 1.2, and if you are still in this forward contract, we would still get 11 million, but we would miss the opportunity of clearing $12 million. So in that case, we would incur a $1 million hedging loss. So the hedging gain and loss, in some ways, a paper gain or loss, in some ways, an opportunity cost or opportunity gain that we should think about. So if you go to the part B, given the expectation of future spot rate, which in this case is exactly as the forward rate. So assuming that forward rate gives us the best forecast of the future spot rate, the hedging gain or loss in this case will be zero. But even with this expectation, leaving 10 million euro unhedged is quite risky, because regardless what your future expectation is, that is just the mean of a possible range of outcomes. So there's a good chance that the exchange rate might end up in the lower end, where dollar might appreciate against euro, and you might actually clear much less US dollar at the time that you receive your euros. So it is a risky bet not to hedge this 10 million euro receivable. So on part C, we were asked to, or the third part, we were asked to whether we would still hedge if we anticipated that the exchange rate would be same as the forward rate. Obviously, we would hedge, because by doing this, we are going to lock into the $11 million receipt. But if you don't hedge, and again spot rate transpires to be something lower, we would incur a loss as compared to it. So forward hedging obviously is safer under all anticipations as compared to not hedging. On part D, we were asked to entertain the thought of forecast of 1.17. So if this rate transpires, obviously we are going to collect $11,700,000. But still, the downside is downside is still there. Regardless of this expectation, the forward hedge is still safer. Now, if you're firm about your expectation, that is the anticipated range of outcomes are on the upside, you can make an argument not to hedge, but for anybody who's involved in manufacturing, marketing, it is advisable just to remove the uncertainty associated with the exchange rate and focus on the core business rather than engaging in a bet on exchange rate. Unless you have some specific knowledge of the FX markets. I mean, it is possible just to exploit that knowledge, but unless you have really expertise in FX markets, you should always choose to hedge and focus on your business. So let's now look at another question. In this question, IBM purchased computer chips from NEC. Which is a Japanese electronics company, and was billed 250 million Japanese yen, which is payable in 3 months. In this particular case, we have a US company that is importing computer chips from Japan, and has a $250 million payable. So there is a liability involved in this case. Currently, the spot exchange rate is 105 yen per dollar, and the 3-month forward rate is 100 yen per US dollar. And also we have the 3-month money market interest rate as 8% per annum, and and in the US we have 7%. I'm sorry, 8% interest rate in the US and 7% interest rate in the US. Per annum implies, regardless of the maturity that we're talking about, in this case, 3 months, these rates are reflecting annualized interest rates for that 3-month period. The management of IBM decided to use a money market hedge to deal with this yen account payable. So we will explain the process of a money market hedge and compute the dollar cost of meeting the yen obligation. And also we will conduct a cash flow analysis of the money market hedge. That is what will happen during this hedge. Again, just to summarize, we have a $250 million payable as, let's say, IBM. And we would like to lock into a certain amount of US dollars that we're going to pay in 3 months, rather than taking the risk of Japanese yen maybe getting stronger. If that turns out to be the case, then we would have to pay a lot more dollars to deliver 250 million Japanese yen. So let's first look at the structure of the money market hedge. So since we have a obligation to pay 250 million Japanese yen, we would like to have 250 million Japanese yen available in 3 months. So we can actually fabricate that by using money markets. So what we can do, we could purchase a certain amount of Japanese yen today, deposit those Japanese yens to earn 7% annual return, or 7% annualized return for a 3-month period, to become 250 million Japanese yen. So in order to be able to do that, we need to be able to purchase that particular amount of Japanese yen today. So we can then calculate the amount of dollars that we would need to be able to purchase that amount of Japanese yen. And then we can go ahead and borrow those US dollars that would allow us to purchase the amount of Japanese yen that we need to have today, so that we can deposit that amount for a 3-month period, which then the amount is going to grow to 250 million Japanese yen. So let's look at the sequence in here. To figure out how much Japanese yen we will need today, we need to discount the 250 million Japanese yen for a 90-day period at the rate of 7%, which in this case it is going to be 241,545,893. So this is the amount of Japanese yen that we need today, so that if we deposit this at the 7% rate, it grows into $250 million. So it is in some ways a reversal of the compounding. So if we had 241 million Japanese yen today, we could deposit it to earn 7%. In 3 months, it grows into 250 million Japanese yen, which is going to allow us to pay the NEC. Now, in order to be able to acquire 241.5 million Japanese yen today, we need, at the current prevailing spot rate of 105, we will have to pay $2.3 million, or to be exact, $2,300,437.08 today, so that we can get this amount and deposit it to grow into $250 million. So where do we get this 2.3 million US dollars? We go ahead and borrow at 8%. If we borrow it at 8%, in 3 months, we will have an obligation to pay $2,346,445. So now we know that in 3 months, by paying $2,346,445.82, we will be able to make 250 million Japanese yen available to pay out our obligation. So in other words, our Japanese yen obligation of 250 million Japanese yen will cost us in 3 months $2,346,445. So this is actually a guaranteed amount because we set it up in such a way that the cost of paying 250 million Japanese yen does not exceed these amount of US dollars. So this is the essence of the money market hedge when we have a foreign currency liability. So essentially, if we have a foreign currency liability, we acquire the present value of that liability calculated at the foreign interest rate, and then we convert the foreign currency amount into local currency that is going to allow us to purchase the required amount. And then we will assume that that domestic currency amount is going to be borrowed at the prevailing interest rate. And that will give us the actual cost of paying this foreign currency liability. So this is how we approach to the money market hedge. So if we locked into a forward rate, which is 100 Japanese yen, our cost would be actually $2.5 million. So this rate that we achieved through money market hedge is more advantageous than the forward rate of 2.5 million, or in this particular case is 100 Japanese yen per US dollar. So the arrangement that we have actually is much more advantageous arrangement as compared to forward contract. So again, to summarize, we borrow $2.3 million, buy Japanese yen at the spot rate of 105, 241,545,893. And then we deposit this at the rate of 7% to grow into 250 million Japanese yen. And the amount that we've borrowed has to be paid back, which will require us to pay back $2,346,445, which will lock us into a cost of this amount. And if you calculate the rate that transpires at this particular ratio, we are able to acquire 106.54 Japanese yen per each dollar, which is actually much better than 100 Japanese yen that we get through the forward contract. So in some ways, the cost of acquiring Japanese yen at this particular rate at 106.54 is $0.0939. In contrast, if you use the forward contract, it will allow us to acquire 1 Japanese yen at the rate of 0.01 per Japanese yen. So obviously, whether we are looking at from this perspective, which suggests that we can get 106.54 per dollar versus 100 Japanese yen per dollar. Or we could just reverse this and say that we will have to pay $0.0939 per Japanese yen versus $0.01. So obviously, this amount which transpires from our money market hedge is more advantageous.